part 2 of the answers video for lessons 3 and 4 of log equations. So let's continue on. We'll finish this assignment here. Okay, number 9 here is kind of complicated looking. It's the 5th root of everything you see under this radical sign, under this root sign, and it's log base 2. So there's a lot of stuff going on there. So the first thing you do is you follow the basic rule that a root to the nth, an nth root of something, is expressed as this variable x to the 1 over n power. So this becomes, the n becomes a fraction, 1 over n. So we're going to do that with this problem right here. So I'm going to start by rewriting it over here. Okay, so there it is. So what we're going to do is change it to this. Okay, so this 5 here becomes to the 1/5 power. Now we can use rule number 12, which is that if you have an exponent inside of a log, you can bring that exponent out in front of the log like this. All right. Now we're going to use rule number rules number 10 and 11. These two, that log of a times b equals log of a plus log of b, and log of a divided by b equals log of a minus log of b. So remember what we're doing here. We're expanding this. That means we're trying to make the word log appear as many times as we can, for lack of a better explanation. That's what expanding means. Okay, so what we're going to do, the 1/5 just kind of sit out here for a while and do nothing. Back for the rest of the problem. We're interested in this part of it. So we have an x times a y to the 4th, and then all that's divided by 16. So we're going to write that like this. Okay, so we take this times this, means it's going to be a plus sign between them. X and the y to the 4th is a plus sign between them. And then all of that is divided by 16. So we are going to then put a minus sign of minus 2 log 2 16. Okay, there's only a couple more things we can do to this. We don't need to distribute this through. There's really no need to do that in this problem. If you do it, fine. If you don't do it, fine. But we have an exponent. We can bring that out in front of the log. That's part of expanding and simplifying this. The other thing we can do is log base 2 of 16 is an actual number. We can actually figure out what that is, okay? So let's just go ahead and do that piece by piece. So we have 1/5. Log base 2 of x. You can't change that. That's simplified as far as it can go. Plus, now this 4 can come out in front of the log. That's rule number 12. So it's 4 log 2y. Okay, so we've taken care of that. And then minus log base 2 of 16. So remember what that means. It means what exponent do you have to raise 2 to get 16? So that you get 16. What exponent do you raise 2 by so that you get 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 2 times 2 times 2 times 2. That's 2 to the 4th. So this simply reduces to the number 4. It's the answer to the question, what do you have to raise 2 up to, what exponent, in order to get 16? The answer is 4. So that's what equals that. Okay? And we'll put a parenthesis there, and we're done with the problem. There's no need to, you could write 1/5 of this, and then it'd be 4 times 1/5 would be 4/5 there. And then this would be 4/5 there. 1/5 times 4 would be 4/5, okay? You could do that. I don't think that's necessary as a simplification. So that takes care of that problem. All right, let's go on down to 10. Okay, now they're asking us to condense. That means we're going in the other direction. We're going from several appearances of the word log down to 1. All right, so what principle do you use for that? So it's a plus, so the plus is log of a plus log of b equals log of a times b. So we're going to go in this direction this way to end up over there. First thing you want to do, however, is you got 6's in both of these terms, so you can factor the 6 out. So we can change this to 6 times. Okay, there. So that's the first step. And now you can use rule number 10 to combine those. Okay, so that's u. V means u times v. If you want to put a dot there, you can, but you don't need to. It means u times v. So that's what rule number 10 said you do with that. So this is your final answer. It only took 2 steps to get there. All right? And that is how you condense. Okay, let's go down This one's really no different. It just has 3 terms in it, but go ahead and condense that. Now, you can't factor out the 3, the 5, and the 6 the way you did the 6 up here. So how do you deal with those? Okay, so again, pause, give this a try, and then come back when you think you've got it or when you think you're stuck, and let's see how we do it, okay? All right, so the first thing I'm going to do in this one, remember if we had an exponent up here, when we were expanding, we would bring it out front. Well, now that we're condensing, we're going to go in the other direction. So this is going to be log base 4 x to the third. We put that 3 up above the x, okay? We're just going in the other direction from what we've done before. Okay, so just put all of those things up above there. And now we're going to use rule number 10 for this. You got a plus sign, so you're going to multiply these 2 terms right there. And you have a minus sign for this z to the 6, so we're going to use rule number 11. If it's a minus, it goes down on the bottom. It's divided by that. So it's going to look like this. And that's your answer right there. Again, 2 steps to get that done, okay? It's not as hard as it looks sometimes, as long as you know the rules. All right? Okay, let's move on to the last page. All right, problem number 12. So again, pause the video, see if you can do this. It's just the same as the last 2. It's really no harder than the last 2. Okay? So pause, and then we'll come back and do it. All right. So if you gave it a try, good job. So what we're going to do is same thing with these coefficients. We're going to make them as exponents, like that. There's no base to this log. That means it's base 10. Okay, so you have that. Now you can combine these using rule number 10. Okay, so here you have neither common base nor do you have common exponent, so nothing's in common. So you're done with the problem right there. That's as far as you can simplify this. Yes, this does equal the square root of x, but you don't write it like that inside this equation. I guess you could, but generally you leave it like a fractional exponent. Okay, so that is your answer. All right, let's keep going. Okay, how about this one? So again, they're all base 10 logs. They have to all be the same base in order to combine them the way that we're doing. If one of them is a base 5 and another one's a base 10, can't do it. All right? Okay, so let's go ahead. So we have a plus sign there, a minus sign there, a minus sign there. So it's simply going to be, you don't have any coefficients in front of the log, so you don't have to do that. So we're just going to do this. So these are the 2 on top, and then it's minus and minus. It's not a double negative minus. This doesn't turn into a plus sign. It's just minus this, you get an answer, and then minus this, you get an answer. So it's going to go, those are going to go on the bottom. Okay, and that's what that would look like. So just kind of stare at that for a second and be sure you understand how we got what we got. Okay, now there's one more thing you can do. This goes back to polynomials here. You can factor this, all right, and simplify. So x squared minus 1. See if you remember that principle. It's this one. It's the difference of squares. A squared minus b squared equals a minus b times a plus b. Okay, in this case, the a is the x and the b is the 1. So this is going to be, this is a perfect square, 1 is a perfect square, so this is going to be equal to, go ahead and rewrite it over here, log of x times x plus 1 times x minus 1. Okay, this equals x squared minus 1. Then down on the bottom it stays the same. Okay, and then one last thing you can do is you can cancel x plus 1, x plus 1. So you can simplify that, so your final answer is going to be this. Okay, and that's what your final answer looks like. All right, that one was a little longer. That was about 4 steps, actually 3 steps. 1, 2, 3. Okay, none of these are really that long. Okay, last problem. Okay, this one is just simply a change of base. There's no other way you can do this one. It's just going to be a change of base problem. So we're simply going to say that this is equal to log of base 10. Again, I'm just writing the 10 to emphasize it. You don't have to. That means 10 if you don't write anything there. But we get to pick that base. So we choose 10. And then it's of the bigger number on the top over log base 10 of the smaller number on the bottom. Okay, so you go to your calculator, and we're going to figure out what the log of 57 is. So we're just going to type in 57 and then log, hit the log button right there in the middle. And it's 1.7. I'm going to go to 3 places after the decimal because the rounding kind of messes this one up if you don't. I'm actually going to go to 4 places. So it's 1.75587. So that 7 that's kind of in the middle there is going to round the 8 up to a 9. So that's going to be 1.7559. So I'm going to 4 places after the decimal because I found when I did this problem in class, it doesn't come really as close to the answer as I would like when you check it out. Okay, so I'm going to clear that now. And now we have to do log of 16. So 16 and log again. And that gives us, I'm going to go 4 places after the decimal, so that's 1.2041. Okay, so I wrote down those numbers on my page as we were doing that. So now you simply go to your calculator and you do that calculation. And that gives us 1.458, and I'll round the 2 up to a 3. I get a 2. I'm rounding it up to a 3. I'm just doing this on my handheld calculator. Okay, and that's your answer, but we can check it out. What this is saying is that 16 raised to this exponent will give us 57. So let's just check that out. 16 to the 1.4583 should give us 57. So let's go to our... Okay, so I'm just going to do this one on my handheld calculator. It's 16 raised to the power. That's the little caret, the little hat. And it's 1.4583. And that gives us 57.01, which is pretty close to 57. Okay, so that's close enough. So we're going to use the squiggly equal sign, meaning approximately equal to 57. It's close enough. It's only because we rounded down that it wasn't exactly 57. Okay, so that takes care of the answers for this, so you can get all these in. Again, if you're really planning to go on with math, practice them so that you can do them. The real test is, can you do these problems 3 days from now without having looked at them in those 3 days? So that it sticks, in other words, so what you're doing sticks in your mind. Okay, so first to worry about today, just get to where you know how to do them all by yourself without looking at the answers, and then that's your first step. Okay? All right, so we'll see you in class. Bye-bye.